Okay, for the 2020 10A problem 16, which was also the 12A problem 16. A point is chosen at random from within the square in the coordinate plane whose vertices are 0, 0, 20, 20, 0, 20, 20, 20, 20, and 0, 2020. That's a lot of 20s. The probability that the point lies within d units of a lattice point is 1/2. A point xy is a lattice point if x and y are both integers. What is d to the nearest tenth? Okay, the first thing you want to think about is if you were to try to graph these points, the 0, 0, 20, 20, 0, all around the square, you're just going to create a grid with a bunch of squares inside, right? And so all of those squares have an equal chance of being the square that the point lands in. And once within that square, the probability from one square to the next that it's close to a lattice point within d units of it is the same. So we actually have a bunch of symmetry, and we can just use one of those squares, the grid squares, where this will be, like 0. We can use the first one, 1, 0, 1, 1, and 0, 1. We can just use this as a proxy to represent that, because within every grid square, it's got the same probability of this occurring. And since the area of this square is 1, we want to know what is the area of the region closest to these lattice points. And so within d units of it. So we're just going to make, if you think about what's within d units of a single point is a circle. It's talking about the radius of a circle. So we're just going to have a circle that comes here, right? But we only need the quarter circle part of it. So we've got a radius of d. All of these points will lie within d units of this point here. And a similar thing will happen over here, and over here, and over here. So you're going to have 4 quarter circles, which is the total of one circle. And that circle is going to have area pi d squared. And since the area of the square is 1, we want the area of the 4 quarter circles to be 1/2, because that's the probability. 1/2 out of 1 is 1/2. So we can just set this equal to 1/2. Let's do a substitution. I'm going to do 22 over 7 and multiply by the reciprocal. D squared equals 7 over 44. At this point, I think we're just going to find a decimal representation of this. I'm not quite sure how to progress with that. So if you do 44 goes into 7, it goes in 0 times. You put a 0, you get a 1, 44. 26, drop a 0, it's going to go in 5 times. 5 times 4 is 20, 220. And so you'll have 40 left, drop a 0. It's now going to go in 9 times. It'll be 10 times 44 minus 1. So 440 minus 44 is 396, giving you a 4. It's going to go in 0 times, and it'll round up to a 1. So 0.159 is what we want to use, and we need to square root that. 0.1591. So this is really close to 0.16, right? And if I square root 0.16, it will be 0.4. It's not exact, but it's close enough. So the answer is going to be B. Okay, and now the 2020 10A problem 17. Define P of x equal to x minus 1 squared times the quantity of x minus 2 squared all the way to x minus 100 squared. How many integers n are there such that P of n is less than or equal to 0? Answers here. So the first thing we want to do is we're looking for where, if you think about it as a graph, you're looking for where it's below the x-axis. And if it's got a positive coefficient of 1 right here, so it's going to look something like this, right? Let's do it on the graph, actually. So it's going to go something like this, right? We don't know how high it goes, but we know it's dipping up and down, and where this happens at is at the roots. So the first root is 1, the second root is 4, and then 9, 16, 25, 36, and so on. Now, we can see it's below the x-axis here, or equal to it, which is also okay, for all the integers 1, 2, 3, and 4. And also for 9, 10, all the way to 16. And also for 25 to 36. So how many integers are here? There's 4. How many here? 16 minus 9 is 7, plus 1 is 8. Here, 36 minus 25 is 11, plus 1 is 12. It looks like we're just going to keep getting multiples of 4. How many are we going to get? Well, for every 2 perfect squares, we get one of these multiples of 4. There's 2 here, 2 here, 2 here, and we have 100 perfect squares, so we're going to get 50 groups of this. In other words, it's 4 times 1 plus 2 all the way to 50. Now this has a shortcut. Again, it's n times n plus 1 over 2. Plug 50 in. You get 50 times 51 over 2. This goes in 25 times, but 4 times 25 is 100. Tack on 2 zeros to the 51, and you will find yourself at answer choice E. Okay, in this video we're doing the 2020 10A, problem number 18. Let ABCD be an ordered quadruple of not necessarily distinct integers, so duplicates allowed, each one of them in the set 0 to 3 of the integers. For how many such quadruples is it true that A times D, the first and last, minus B times C, the two middle, is odd? For example, 0, 3, 1, 1 is one such quadruple because 0 minus 3 is negative 3, which is odd. Okay, so for this one, it's a little bit like you're just counting, basically. And what we want to think of is, in order for this expression to be odd, I can have 4 different ways. There can be odd minus odd. That doesn't work because that's going to produce an even. You can have odd minus even, even minus odd, and then the last one, even minus even, is like this one. It's going to produce an even. This will equal an odd, and this will equal an odd. So we just need to count the number of ways first that A times D can be odd. Now the only way you get an odd with the product of 2 integers is if they're both odd. So I would need A to be odd, and there's 2 ways for that to happen, and D to be odd, there's 2 ways for that to happen. Okay, so then it's times the number of ways that BC can be even. Now to get an even, I can have an even times an even times an odd, or an odd times an even. And each of these has 2 ways for it to occur. So 2 times 2, there's 4 ways for this, even times odd, 4 ways for that, and 4 ways for this, for a total of 12 ways for BC to be even. So I multiply those 12 ways with the 4 ways there are for AD to be odd, and I get 48. Now, because this is just the reverse situation, it's going to have the exact same number of ways this does, and we can simply double to get 96, which is answer choice C. Okay, and on to the 2020 10A, problem 19. As shown in the figure below, a regular dodecahedron, the polyhedron consisting of 12 congruent regular pentagonal faces, floats in space with 2 horizontal faces. That's this one and this one. And I apologize for the bad drawing. I'm not the best at 3D art. Note that there is a ring of 5 slanted faces adjacent to the top face. So that's this one, this one, this one, adjacent to this one, and there's 2 more in the back. And a ring of 5 adjacent to the bottom face, these 2 and 3 in the back. How many ways are there to move from the top face to the bottom face via a sequence of adjacent faces so that each face is visited at most once, and moves are not permitted from the bottom ring to the top ring? In other words, I can't come down here, go here, over, and then back up again. Can't do that. Okay, so what we're going to do, I'm going to call this A, B, all the way around to E. A, B, C, D, and E. I'm going to have 5 choices for how to get off the top block. Once I've made that choice, I'm going to have the choice of going, let's say I went to A first. Then I could go from A directly down in 2 ways. So just going from A straight to the bottom ring is fine. There's also going to be A going to B, A going to B to C, A, B, C, D, and A, B, C, D, E. Further, I could go the other way. So I could go AE all the way to, well, we'll just write it out. AED, AEDC, and A all the way back to B around the other way. So how many paths do I have along the top ring choices? I've got 9 paths. 1, 2, 3, 4, 5, 6, 7, 8, and the single A, 9. So there's 9 ways to traverse the top ring. Then I've got 2 ways to get to the bottom ring from any one of these. There will always be 2 that it connects to. And then once I'm on the bottom ring, I'm going to again have 9 paths that I can use to get to here. And so I multiply this to get 10 times 81 is 810, which is answer choice E. All right, and now for the 2020 10A problem number 20, which was also the 12A problem 18. This is a really fun question. Quadrilateral ABCD satisfies that ABC and ACD are both 90. Let's try to make sense of that. I've got A to B. This will be a 90-degree angle of some kind. Here, we don't know how long this is. We know that ACD is also 90. So we'll put C here randomly. And this has to be 90 degrees also. And then it says that AC is 20, which means I need to go that length the same, but then go a little bit farther because CD is 30. Okay, this being 30. Diagonals AC, which is drawn, and BD, which I have not created yet. Let's draw that. Meet at E. And AE is 5, which means this is 15. Don't worry about if it's that accurate or not. What is the area of quadrilateral ABCD? For starters, you've got 2 right triangles. Try to capitalize on that. We know that ACD's area can be written as half 20 times 30, which is 300. Then how are we going to get ABC? Well, we have the base of it right here. It would be really great if we knew what the height was. And so since we have this base, let's just draw the height in right here, perpendicular. And what you're going to notice is you've got 90 and 90, and this angle equals this angle, so these triangles are similar. And so I can call this point here F, and I will call FEX and BF. Because this is 15 to 30, that's a 1 to 2 ratio of base to height in this one. So this is a 1 to 2 ratio, and this will be 2x. And since AE was 5, we can call this right here 5 minus x. Now, how does that help us? Well, there's something about right triangles. When you drop the altitude from the right angle, like this, you create similar triangles. And the way that it works is basically I'll call this M. These are A, B, C, and D. There's 3 different ratios that are created. I'll unpack this in another video probably again, but it's B over M equals M over C. So B over M equals M over C. In fact, the altitude is the geometric mean between B and C. The other 2 are that B over A equals A over all the way across. So B over A equals A over B plus C. And I get the symmetric one going, the reflexive one going this way. C over D equals D over B plus C. For our purposes, though, we only want the first one. And so we're going to travel from A to this altitude's base at F, and that's 5 minus x over, go over 2x, and then this will equal, do a U-turn and come back, 2x over, this whole distance is x plus 15. Now we can cross multiply. 5 minus x times x plus 15 equals 4x squared. Distribute. 5x plus 75 minus x squared minus 15x equals 4x squared. Let's move it all to the right because that's bigger and positive. The x squared moved over is 5x squared. I've got negative 10x moved over becomes positive 10x. And I've got positive 75 moved over becomes negative 75. I can now divide by 5. I'm going to get x squared plus 2x minus 15 equals 0. This factors to x plus 5 times x minus 3 equals 0. That's impossible. X must equal 3, which means the height was 6. That's the height of this right triangle. And the area will be 1/2 times the height 6 times the base 20. Half of 20 is 10 times 6 is 60. And you're going to get D, 360.